I'm Anil Kumar sharing with you some questions on optimization problems. I'd like you to pause the video, copy these questions one by one. We will discuss 6 examples. So you can copy example number 1 and then here are example number 2 and 3. So copy example number 2 and then you can copy example number 3. Correct? So these are the 3 examples on this side of the page, and I have 3 more on the other side, which are example 4, 5, and 6. So copy these examples. We'll discuss them one by one and see how to solve such questions. I hope at the end of these 6 examples, you will understand exactly how to solve optimization problems, right? So these are the 6 examples. In this particular video, we will actually start with the first example and then take them one by one, right? So the first example which we have is Aaron and Tony are creating rectangular banners for the companies attending a convention. Each banner must have a colored border and a white center. The width of the border will be 20 centimeter at the top and bottom and 15 centimeter along the sides. Because of the number of companies and the available space, each banner must have an area of 2.43 meters square. What are the dimensions of a banner if the area of the white center is maximized? So we'll understand the strategies. This is an excellent question seen so many times in test papers. Now here you will note that units are different and the width on both length and width side is also different. So let's make a sketch of the banner. So let us say this is the rectangular banner. Now what we have done here is that we have a border and the central space which is white. Border leaves more space from the top than from the sides. So it is kind of like this. So leaving more space from the top, which is 20 centimeters, and from the sides it is 15 centimeters, right? So that is many times in examples we have same borders, but not in this particular case, right? So that is how it is different in many ways. So we have 20 centimeters on each side. Let me write 20 centimeters. And on this side is 15 centimeters. So let's write like this, 15 and 15, right? So that is how it is. Let us assume that the length and width of this banner is x and y. So we say x and y, right? So we will write x and y in centimeters since these dimensions are given in centimeters. Now let's read the question. Important part here is, because of the number of companies and available space, each banner must have an area of 2.43 meters square. So area is given to us as 2.43 meters square. You should convert that to centimeters square, right? So multiply by 100 and then by 100. So we get 243 and 100 centimeters square. So that is the area in centimeters square. As you know, area will be x times y. So area is x times y. So x times y is equals to 243 100. And that will help you to relate one variable in terms of the other, right? So we can say x is equals to 24,300 divided by y. So whenever you have word problems like this, dealing with two variables, write one in terms of the other, right? Now we need to maximize the central area, right? So after all, how much is the central area? So we have to write an equation for the central area, right? So the central area is outer area minus the border, correct? So that is the central area. Or you could also say that the white space area will be, here if you see, length will be how much? Let's write down. For the red portion shown here, it will be x minus 2 times 15, right? So 2 times, because we are taking away 15 from both the sides, x minus 30. As far as width is concerned, it will be y minus 40. You get the idea, right? So that is the length and width of the central portion, right? So the area which we are interested in maximizing is, we can write area as x minus 30 times y minus 40. So that is the area which we want to maximize. Now in this case, x is 24,300 by y, so we can replace that x with 24,300 divided by y minus 30. So that is the first term, and the second term is y minus 40 for us. This is the area in terms of variable y. Once you get area in terms of one variable, you can actually find the derivative. So let's find the derivative with that variable, right? Well, in two variables also you can solve, but by now we are only learning one variable derivative, so that's what I said. Okay, now what we can do is we can apply the product rule and find the derivative. Derivative of the first term will be, this is y to the power of minus 1, so it is minus of 24,300 divided by y square times y minus 40, correct? Plus derivative of the second term, which is 1, right? Y minus 40 derivative is 1, times the first term, which is 24,300 divided by y minus 30. So that becomes the derivative for us. Now for maximizing the area, this derivative should be 0, right? So we need to equate this to 0 to maximize, correct? So we have this derivative a dash y, that derivative should be equal to 0. So we can now solve for it, right? So we can expand and simplify. So what we can do here is, let's do it on the right side. So for this derivative to be 0, the term on one term should be equal to the other term. So we have 24,300 over y minus 30 equals to 24,300. So we can expand this. So that will be, when you multiply by y, it will be over y, and when you do with the other term, it will be minus 40 times 24,300 over y square, right? So that is what it is going to be. So what we will do is we'll just multiply and write it down. So let's write it down first here, and then we'll take the terms to the other side. So that should be equals to minus 24,300 over y, and when you open this up, you get plus. So 40 times this, so 24,300 times 40, so we get 97,200 over y square plus 24,300 over y minus 30. So that is what we get, right? Now in this, these two terms, they are similar, minus and plus, so they cancel out. So that is why, we'll just cancel this out first and then simplify. So instead of writing this here, let me just change this. So that helps actually. So now what we can do is we have to equate that to 0. That means we get 97,200 over y square should be equals to 30. So when you simplify, you get y square equals to 97,200 divided by 30. So that is how much? 97,200 divided by 30 equals to, and we can do square root of that to get y value. So this is equal to 32,400. So when you square root this answer, you get 180. So the value of y is 180 from here. Now since value of y is 180, you can find what x is, right? So you can write x is equals to 24,300, 24,300 divided by 180. So let's do that. 24,300 100 divided by 180 equals to 135. 135. So 135, these units are centimeters. So for maximum area, you expect that to be the case, right? Now, to show that this is indeed the maximum area, what you should do is, you should test your derivative a dash y. So now a dash y, which is this minus this. So if I have a value which is less than 180, let us take value 0. On the left side it could be 0. That could be the boundary condition. So we could actually find boundary conditions here. And the boundary condition for y is 40. So what can y be? For y, from here we can say boundary conditions. Let me write down. I should have done it before. Boundary conditions for y, that is easier actually, will be 40 since it cannot be negative. And it is, we can find what is x. So x has to be, you can say, greater than equals to 30. So what you can do is, for x equals to 30, you can find the value of y. That is what you can do. So if x is 30, what is y? So y will be, for this, y, for x 30, y will be, right, let me write down here, y is going to be 24,300 divided by 30. So 24,300 divided by 30. So that is 24,300 divided by 30, which is 810. 810. So 810. So y value is between 40 and 810, right? So what you can do is, you can find the value of the function for these two y values, right? For 810 or 40, correct? You'll find which one is the maximum. So for a test point, what we can do is, we can take 40 as one test point. So if I take 40 here and then calculate, and the other point which I could take is 810, right? And find the derivative, the value of the function at these 2 points. So let's do that part. So we'll find, what we'll do is, we'll change the strategy. We'll find the area when y is 180, and if y is 180, we know x is 135. So we can write this for the value of 135 for x, let us say, and 180 y. So this we are expecting maximum area. Also find area when the x value is 30. In that case, y value will be 810. 810, right? Find that area. Also calculate the area for when y is 40, find what will be x. So let's find x when y is 40. So y 24,300 divided by 40. 607.5. 7.5. So you can check for x value, when x is this x value of 607.5 and y value of 40. So these are your boundary conditions. You get the point. So check these values for boundary conditions and for this particular value and compare which one is the highest. You'll find that the one with which we calculated is the highest, and therefore that gives you the maximum area. So the question is, what are the dimensions for the banner if the area of the white center is to be maximized? So the dimensions of the banner will be y is, we have to add, will be, well, that is the answer. So let's write down the answer now. So our answer will be, dimensions of the banner will be, x value is 135 centimeters. So you could say 1.35 meters by 1.80 meters, right? So that becomes the dimensions of the banner for maximum center area, right? But to show that, you have to use calculator, calculate these values and show that this is indeed the maximum. So I'm leaving that part for you to do. I hope that helps. Thank you and all the best.